How are you? Everything all right? Everyone here? Are we missing someone? We're missing someone. Come in. Go, 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 go. Yay. So just to repeat, and maybe there are some new faces here, like there's cold drinks over here. There is coffee, but making coffee is noisy, so probably better after the presentation. The toilets are there, so you have to go behind the speaker to go to the toilets, which is like awkward. Just saying. No? So we have, I forgot your name.
Karthik. So
Karthik. Oh, I asked him like 3 times now. What's
okay.
your name? And I always forget. From SAP here, he's about to talk to us about machine learning with TensorFlow and Google and all that crazy hip shit that I have no idea about. But you are going to tell us about it.
Yeah.
And afterwards, so a short introduction talk, I think, we will go to a hands-on session.
Yes.
Is that right?
Yeah.
So you will have to do something, not just sitting here and watch us talk. And this is why you all brought your computers, which is great. And if you need power, there are power strips on the table. And if you need something else, just ask. Maybe we can help you. Volker is trying to say something to me. Ah, wireless. Yes, of course. There's wireless network available here. There's the password. So that's and there's like food and snacks. Don't hesitate to eat them, because if you don't eat them, we will have to throw them away, and that would be a shame. So please help us. And that's like everything I want to say. And now I give you the stage, and afterwards you a lot of fun, and then give him a warm round of applause to start with.
Thank you. So, could we have the presentation?
Oh, of course. I'm so sorry.
I just connected it.
Yeah, and I blanked the projector. And that's why we didn't see something.
Okay, cool. So, good evening. I'm Karthik. I work for SAP. So I actually drove from Waldorf to Wiesbaden, beautiful city here. I work as a senior data scientist at SAP, and I also work with Google for most of the open source technologies, especially on machine learning and Google Cloud. So what we will discuss today is basically some introduction. So before we get into all of this, I wanted to understand how many of you are new to machine learning? Okay. So it looks like only a few of you guys are new to machine learning. I'm not sure if all of this would basically be a bit of an introduction, because I wanted to give an introduction. I wanted to give everybody a chance to understand what machine learning is about before we spoke about fancy neural networks and all the deep learning and all that. In general, one of my job is to ensure that people understand what machine learning is, and more importantly, what machine learning is not. So, because at SAP, we need to actually talk to customers and make them understand that machine learning cannot solve all the problems. And this is also something that we need to make people understand. And before we, as a data scientist or a machine learning practitioner, understand that machine learning cannot solve all our problems as well. So just because media says all the fancy things, it's not generally true. When you get into developing and deploying machine learning algorithms, you know that it's basically better mathematics. So we will get into all of that, and we will see how and exactly what all of this fits into place. So if you look at it, if you look at an overview in general, so this is basically some slides that Google actually has. So we actually talk about how AI actually started like close to 50 years ago, and what we're talking about deep learning here is basically just a subset. So if you talk to mathematicians wouldn't agree with this diagram, but in general, this still holds good. So in general, this deep learning is still a pure subset of machine learning. We were doing machine learning for the past 50 years or probably 30 years. It's just that it's become more fancy, and it has become more beautiful people, it is made more, it's made to look better on the media. That's all at the moment. And it's also primarily because of the fact that we have better hardware to support all of our machine learning algorithms. And that's one of the reasons why we have good deep learning algorithms in that sense. I'll also talk about what deep learning is and probably also give an idea of why are we talking about deep learning at the moment, what happened. And basically, if you look at in 2012, basically there was this competition which showed that GPUs or graphical processing units that people used to game came into place, and then it actually helped in solving most of the problems. It actually made sure that the challenge won with the deep learning algorithm. The slide here talks about what typically happens. So in general, like I said before, when you talk about machine learning, you need to understand whether you need a machine learning algorithm or not. When you see, when you talk to a customer today, when a customer says, "Hey, I see machine learning. I want machine learning in my, something to do with a simple problem." In general, you don't use machine learning when you can actually solve a problem with rules. So if you can actually say, "Hey, I can actually make things," if I just say monitor my steps, so I have a Fitbit or an Apple Watch, and if I can monitor my steps, and if I say, I walk at less than 4 kilometers per hour, number of my speed is 4 kilometers per hour, probably I'm walking. If it's 4 and less than something else, then I'm running. And so if I can make it into rules, then generally you never go into machine learning because this is going to work 99% of the time. And it's generally more explainable. So this is one of the reasons why we would generally advise not to actually use machine learning at all. And with GDPR in place, what GDPR also talks about is if your customer asks for explanations, you have to give an explanation. When you say, "I have a fancy neural network, I don't know what is happening," that's not going to be a valid answer to your customer. So in this case, you need to basically explain. And in general, if you can do if you can solve your problem with rules, then generally you don't need machine learning at all. So coming from someone who's actually practicing machine learning on a daily basis, this is a bold statement, but yes, this is true. So if you can solve a problem with rules, generally don't go for machine learning at all. That's a pretty standard statement. However, things fall into play. Generally it does not, happen, and you will get into a situation where standard rules cannot solve. And this is where machine learning can actually help solve your problem. So non-linear functions can be really, really learned well by a machine learning algorithm. And this is where we will be talking about. So especially if you've not seen, if you've never developed a neural network before, today you'll understand some simple algorithms that can actually say, solve your rules or figure out these rules for you. So in effect, what will happen is, I think there is also a slide over here. Yeah, this is exactly. So the traditional machine learning is where you have rules and you actually feed data to it, and then you actually get answers. But in the other sense, what will happen is, you actually feed the answers and the data, and machine learning actually spits out the rules. So effectively, this is what is happening at the moment. So you have a neural network or a model that's actually being trained, and what the neural network is saying on the other end is that basically it's saying that these are what is happening. So with your data, this is what I see. So I see that, okay, you give me some fancy records, and you say that, okay, this is not what it is supposed to look like, and I say, okay, let me then try to fit it. So this also comes back to something called bias, and human beings in general, we are biased. In general, I look at someone, my brain is tuned to actually think about, okay, who's this what person is, where is this person from? Is this what gender, what is the person's gender? Is this person tall or short? So all of this actually goes through our mind because it's evolution. So we've done this through evolution through millions of years. But this also knows the fact that most of the data that we create is also biased. So this is one of the shortcomings of machine learning as well. So if you look at what we're feeding the machine learning algorithm, we are effectively feeding it the answers as well as basically the data. So what happens is the data that we produce is already biased. And when you're going to feed this biased data along with the answers, we are going to make the machine learning algorithms also biased. And I think if you read news articles and things like that, you would actually have seen Google and Amazon and all of these companies actually getting in trouble because of the fact that the bias, the data, there was data bias in the data. And this is something that is also very active research that we're also working on into ethics, into bias, into fairness. All of these are very, very important topics. All along, we've done fancy neural networks, making it 154 layers deep, getting it 99% accurate, and we've done a fantastic job with all of that all along. But what we realized sooner or later is that this is not sufficient. To a customer, to a human being, if I'm going to make 99% versus 94%, it's not going to add any value. But the point is, if I'm going to be biased, if it's going to say, hey, you are basically, you are a guy and you have certain characteristics, if you're going to be stereotyped versus someone else is also going to be stereotyped in some other case, then this is a problem. So this is where we are going to come in, and this is some areas of research that are also going on. But in general, this is something that I also talk about in general, because at this moment, when someone is starting with machine learning, you need to understand that just because you have some data and you get some results is not going to solve your problem. You need to understand implicitly, is your data fair? Is your data biased? If you understand that, you can actually develop a reasonably good algorithm. So one more point I also wanted to say is, please don't, I'm not giving a lecture here. So if you have any questions, this is not college, this is not school, this is not university. You can ask me questions immediately. Let this be as interactive as possible. I can walk up to you, or you can interrupt me. Please feel free to do so. Just wanted to keep you updated there. So, having said that, what are we effectively doing with a neural network, or what we are trying to do is we are actually mapping all these features or all these inputs into some sort of another representation. This is typically called a feature. And things like, again, like I said, if we take, for example, a car, what is the brand? What is the color? How many wheels? What is the type of engine? How many liters? Is it diesel? Is it petrol? All of these components are going to be different features for to describe a car, for example. So just like that, so is it going to be walking? So is this person, how fast is this person walking? Is this person's stride length so much? So these are all different features that we can use to categorize this again. So this is what we do. This is typically called a supervised learning. So where you have this label, so you have this input vector or input feature, and you're basically saying this is what this means. So if you basically walk less than 4 kilometers per hour, then you're typically, if you're moving at less than 4 kilometers, then you're typically walking. So this is, again, just an idea of what is actually happening behind the scenes. And this is why it's also called a black box. Effectively, it's not generally human readable. So unless you are probably like Alan Turing or someone who with a fantastic mathematician, who you can add John Nash, who can actually understand just given this binary number what that means. In general, we cannot perceive what's happening behind. In general, it's also a vector. So it's basically a matrix or in a vector which is going to say this is a representation of a particular feature. And this is one of the reasons why we can also not explain. So a neural network is going to take an input and it's going to convert it into a vector. And in general, when your customer asks, why can't you explain it? Well, because this is the reason why you can't explain it. It's going to be a set of numbers, a set of floating point variables, which are going to be representative of the input data. It could be an image, it could be a song, it could be a video. It's basically going to convert it into a string of numbers. And effectively, it's not human readable, it's not human comprehensible, but generally what will happen is because your neural network learns what to do with it, it will know exactly what that number effectively means. And this is the reason why we are actually trying to go back and say, okay, let's take a step back. Can we actually explain this? And this is where lots of research is actually going on as well. So, yeah. So like I said, so if we have 3 labels, can we actually label another one? That's, again, different areas of research called one-shot learning, few-shot learning, and things like that, which actually come into play, where it's going to say, I've learned these 3 features. Can I, these 3 activities, can I actually generalize and say, given a new activity that's neither of these 3, can I actually classify it? So this is another area of research, which is actually a very interesting area of research as well. So either you're given no variables at all. Human beings are excellent at this. So if you go to a kid, if you teach a kid, say for example, give the kid a toy dog, and then take the kid, give it just one dog, and then take the kid on the street, and the kid will be able to identify immediately any other dogs on the street. But a computer will not be able to do that. You can take that. Of course, I don't want you to take your computer out to the street, but effectively, if you're going to teach your computer one particular dog, it's not going to see another dog and say, "Hey, I actually saw this. This is a some sort of a new dog," but it's not. So it's not going to do that. In general, you need to. This is one of the reasons why you need a lot of data. You need to show it a lot of examples before it can actually understand and generalize on a given particular class or given particular category and things like that. So, having said all that, yeah, so we actually do, this is what effectively neural network looks like. So you will see that this is where also you have, let's not get into all the details. We probably are already 20 minutes down. There is going to be different talk about training phase. There's going to be a prediction phase, inference phase. So prediction and inference are basically the same. So once you've trained a model, you are going to use that model to basically say, predict new data. So that's all. On new data, can you actually do this prediction or inference is effectively the same. It's just a different jargon, that's all. So effectively, this is all that's happening. So you train a model, and then you deploy the model, and then you test it. So, and in general, all of this will happen at different times. So you need input data there, you need train data, validation data, things like that there. And in this side, you will have completely new test data that you would like to test. So these are different examples of where deep learning is helping out. So this is in actually identifying the blood pressure and then actually predicting whether you're going to have glaucoma or things like that. There is also a beautiful example of how deep learning has been used in predicting different solar system activities. Again, this is an example where I think in Switzerland, they actually figured out, the disease of cows, or there are lots of examples where deep learning actually helps out, and there are lots of examples. You can actually go, and then I can actually share this slide as well after this. But your smart reply on Gmail is also an example of machine learning or language. This is language training. So effectively, what Google is doing is it's trying to understand how you generally reply, and then it's trying to understand this language model, and it's building a language model behind the scenes. So this is why the minute you start typing, it's also leveraging a lot of people's data and your data, and then it's called fine-tuning effectively. It's doing it on your data, but it's actually learned from billions of people's emails and how they've written some sort of sentence and things like that. And that's a standard example of language learning, language pre-training, for example. These are all different examples of how Google, or in general, how machine learning has been used very, very successfully. So, how many of you have learned, or how many of you have used, or how many of you have seen TensorFlow? Okay, quite a few. That's nice. Have you guys used PyTorch? Any of you use PyTorch? Okay, that's new. Okay, so in general, I would like to keep things open. So TensorFlow is one of the libraries that is used in general for a good computation in general as an open source Apache 2.0 licensed library. There are also other frameworks, other deep learning libraries called PyTorch. There were a few more called CNTK, Caffe, and things like that, which became pretty much obscure because of the fact that PyTorch and TensorFlow pretty much rule the roost now. So if you talk about any research papers in general, PyTorch has a very good research community which actually implements papers. And if you're generally into natural language processing, and there you'll get a lot more resources also on PyTorch. So I just wanted to keep things open. I don't want to say that this is the only thing that you have to learn and you have to do. TensorFlow is also one of the best deep learning or computational libraries that you can use. And in general, Python is the preferred front end. So today what we will do is we will use a lot of, is there a question? Yes.
What is PyTorch compared to Keras?
Okay, perfect. Super. So Keras is basically a high-level API. So what Keras does is, we'll also see some examples in Keras. TensorFlow also implements Keras now. Keras is basically a high-level API. So it's basically like, say, for example, C++. And you write a wrapper around, say, the core C++. Then what happens? So Keras is something like that. You make your underlying low-level APIs much more easily readable. So what Keras has done is it's made a very beautiful API that can actually make your life much easier. So if you typically generally use scikit-learn back in the day, or even people use it today, it has a very simple .fit, .predict, and .probe and things like that. So what Keras has done is it's followed a similar pattern, and it has actually created a high-level API. And what the Keras team has done is made this extremely successful that a lot of libraries actually use Keras now. TensorFlow uses it. Actually, this is the first-class citizen at the moment. So if you see TensorFlow 2.0, Keras, I'll also show that example. So best effectively, TensorFlow is a low-level machine learning library or computational toolkit, and PyTorch is also on the same lines. What Keras does is it actually goes one level above, and then it makes life easy for developers. And effectively, developing if you want to develop machine learning algorithm, it makes life easier by giving you a very simple set of APIs that you can actually write, and then you don't have to worry about garbage collection and things like that. If you have to say deploy a model, Keras makes life easy in that sense. And we will see an example where TensorFlow also uses. In TensorFlow 2.0, Keras becomes the first-class citizen. So the first way in which you actually develop a neural network in TensorFlow at the moment, in 2.0 onwards, would become Keras. So I will show how that is also working now. So yeah, at the moment, this is a pretty old slide here. This is now, even now, it's actually number 1. But yeah, let's not go into all of this. Let's just skip all of this. Yeah, this is what I said. So at the moment, you see basically tf.data, which is going to be the way TensorFlow reads data and then consumes data. So you can actually streamline this, and then you can actually store it in a particular protobuf format. What will happen is you can either use TensorFlow's low-level APIs or TensorFlow tf.keras. So tf.keras becomes the high-level API that you will be calling to actually learn and develop a deep neural network. So this is something maybe if we have time, we can also go through how we can do that and have a simple example as well on that. But effectively, what will happen is, yeah, if you have multiple GPUs and multiple CPUs and multiple TPUs, for example, what TensorFlow does is it makes your life easy. It actually has a distribution strategy which will actually easily scale out, and then it will actually bring back all the parameters into one single place. And this is what TensorFlow does extremely well. With PyTorch, there is this limitation. This cannot be directly done. PyTorch has some limitations, which TensorFlow actually does extremely well. And TensorFlow is actually, when you write code, it actually becomes production ready straight away. You can write code on a research paper and then bring it straight into production with a TensorFlow serving pipeline, and you have very nice, well-written documentation with TensorFlow. On the other hand, PyTorch is trying to come there, but it's not yet there. I think sooner or later they will be there. But at the moment, yeah, just to give you an idea of what are the shortcomings here and there, TensorFlow is at the moment still winning by a large margin, but PyTorch would probably sooner or later catch up there. But the community-wise, TensorFlow is significantly larger, and there is a huge community across on the internet. Locally, if you'll actually see a lot of Google GDGs and a lot of communities also helping TensorFlow and talk about how we can actually develop neural networks as well. So yeah. So effectively, yeah, these are different things. This is on this side is where, again, TensorFlow wins hands down. So if you look at the TensorFlow serving, again, like I said, you can move into production straight away, no problems asked. So we are doing that at SAP as well. When we develop a neural network, we have TensorFlow serving pipelines, which moves code directly from research into production. On the other hand, when you're going to have, say, if you're going to develop an application on, say, on a mobile device, then TensorFlow would do that as well. So TensorFlow Lite is where it actually takes a trained model, converts it into, say, if you have an iOS device, you can actually push it onto an iOS device or an Android device. Of course, Android device takes first class, but Swift for TensorFlow actually does a very good job at the moment, and also taking your code from research and moving it into an iOS device as well. There is a huge push on Swift for TensorFlow as well. So that's also an excellent push there. PyTorch does not directly support that at the moment. TensorFlow JS is another. If you're a web developer, this is a pretty cool feature. So I can actually show you an example of what's happening with TensorFlow.js. You can actually run your TensorFlow model on your mobile phone and straight on the browser. So that's how cool it is. So with 20 kilobytes of neural network that you can actually run on your mobile phone, that was never seen before, and it's actually possible with TensorFlow.js. So if you have a Node.js server, you can actually deploy it, and then you can do fancy things as well. But yeah, so all these are possible with TensorFlow, and this is what shows. So the last thing is TensorFlow Hub, where a lot of trained models, pre-trained models are given away by the community and by Google. What happens is it lets you not train the model again and again. Instead, you use someone else's trained model, and then you will try to deploy it, or you can actually use it for your own applications, and you can develop on top of that. So that's the idea with TensorFlow Hub. So yeah, there are quite a few platforms, especially on Raspberry Pi. This is a pretty new thing that's also happening. So if you're interested in, say, deploying something like an IoT device, I'm actually doing one at home to actually monitor my plants. That's actually a fancy algorithm that's actually running for a very simple task. I am, at the moment, it's a bit of an over-engineering, but it's still fun, a lot of fun when you actually have a Raspberry device lying around and you would still like to do some fancy machine learning algorithm. But nothing fancy about it. It's about how you can get something so small like a Raspberry Pi to run a complex neural network to do something very, very interesting. So that's all about it. And then you can think about face recognition and all that on a Raspberry Pi. So if you want to mount a face recognition system on your door, then you can do that as well. So you can actually get Google's AI project and then AI project. You can actually mount it on your doorbell. And then you can actually, the moment someone shows up on your door, you can actually see if that person, you know that person. If you don't know all that, you can actually do all that. That's also possible. But yeah, these are some ideas that I also tried. And yeah, it works well, but in general, it might not be necessarily useful in the long run, or you might need more data and you might need more patience in general. So yeah, I don't want to go through TPUs and all of these. I think we will skip this at the moment. If you're interested, we can go through this. But this is how the old TensorFlow code looked like. But with TensorFlow 2.0, what happens is, like I said before, tf.keras becomes the first-class citizen, and you will make things. It makes life easier. This was never the case before. If you've written code in TensorFlow 1.x, life was pretty much bad. You need to write a session. You need to run things in sessions. Let's not get into that. It's basically, it was not very user-friendly. Now, things are much more competitive, and you actually, all the compute runs like NumPy, for example. And yeah, you can actually write things which are much more clear, much more consistent, much more intuitive to understand, because again, like I said, TensorFlow leverages Keras. So let's not worry about all of this. One thing, if at all, you would like to do, I would like you to take home is basically this one. So if you're interested, go to colab.research.google.com. So this is a very, very useful resource. If you're running, say, for example, if you want to, say, train a neural network and you don't have a GPU, for example, Colab will come to your help. What Colab is basically, so just before I go into what this is, how many of you have used a Jupyter Notebook? Okay, a few. So then I will just give you an idea of what this is I'm showing here. This is basically a Jupyter Notebook in some sense. What Google has done is Jupyter Notebook is basically a web application which runs or not Python, but necessarily a lot of kernels behind the scenes. Jupyter, as you see, stands for Julia, Python, and R. So that's why the spelling is Jupyter. And actually, it also supports a few more. There is also a C++ runtime that you can configure, and you can do a lot of things with it. But if you see this very simple, this looks like a web page. But what it can actually do is it can actually run neural networks over here. So if you see this example, you're going to actually, what we are doing at the behind the scenes is basically downloading some data set, and we're actually extracting the questions from the data set, and we're actually saying, okay, let's print it. But I think we've not done some initialization before. Yeah, over here, there is a setup environment, which I've not run. Let's run that as well. But you see, it's very, very powerful. Google gives you, if you see the runtime, you can actually have a GPU, or you can actually run a TPU. if you want to go fancy, you can run a tensor processing unit or a GPU. GPU here is a T4 GPU. So if you want to run or if you want to learn neural networks, and if you don't have a GPU or if you don't have resources to, if you don't want to basically ask your manager to buy you a GPU, this is a wonderful resource. So you can run, any of the your experiments over here. You can see the results straight away. So this is a Jupyter notebook where your code runs and the output is actually shown right below the cell. So this is one of the reasons why I wanted to show this and then have you know that. So when next time when you want to try a neural network and you don't want to run something, then go to Colab. And one thing, again, I would like to stress is do this for experimentation purposes. Don't take customer data over here. This is something that I would like to say every time and any time. This is purely for experimentation and for you to have fun and to learn. So if you're going to take customer data, the onus is on you. The responsibility is on you. Of course, if your customer clears it, then go ahead, because the point is that this data is going to lie on Google servers. So if your customer is perfectly fine with that, go ahead and enjoy and try to see if you can actually make a neural network learn. But yeah, so this is an example. I can actually show you a few more examples, but effectively what will happen is if I run this now, it will basically say, like you say, it has downloaded this data, and then it is actually looking at the data, and then it's printing out the results over here. And if you see below, it's also saying how much time it took, and you can also do a lot of fancy things with Jupyter notebooks. And with Colab, what happens is you can keep everything in one place, and then you can actually share this and simultaneously work with people and things like that. Again, it's an open source library. It's an open source system. I just want to share this so that people can have access to more resources and know about things before you get into buying a GPU and wasting money on GPUs for a single experiment. So this will be really useful effectively if you want to learn machine learning and if you don't want to spend money on GPUs. So this is one of the reasons why I want to share this. So if there are any questions, I'll be happy to take. Of course, yes. So whatever I share will be for free. So otherwise, there's no point, and I'm not trying to make money here. The idea is to make it into a community effort, and if it's for community, I want to make sure that people get free access to education and basically resources, so that you don't have to run for resources. This was not the case like 4 or 5 years ago. Now everything is available on every browser. So this is why I wanted to share all this. You can, if you're interested, you can actually download the Colab code and run it on your server also. If you don't want Google to run all your data on your compute, but this is of course for free, and so that is also one of the limitations. So because Google is allocating resources for you, there is any chance that the GPU might go away. So it's just that you have to reconnect. That's all. So that's not a big deal if you're experimenting and things like that. So yeah. So these are some examples. So text generation. I have some examples as well where you can actually feed in Star Wars scripts, and then what the neural network will do is effectively produce a new Star Wars script. I think there was a recent article on Game of Thrones. So basically what they did was they fed all 8 seasons script of Game of Thrones, and they actually made the neural network write an alternative ending to basically Game of Thrones in the 8th season. But that was a very nice idea, but I think it was not really interesting, but it is a good fun weekend project, especially if you want to learn machine learning and how things work. So yeah, these are different things. Again, I don't want to spend time here. If this is the first time you're looking at Keras, and this is the first time you are looking at what a neural network is all about, so this is how generally a neural network, a simple neural network, I would say, looks like. You see there are 2 dense layers with 1 dropout. Let's not go into detail over here. What it's doing is you have fully connected layers over here, which is fed, which has some non-linear activations. And it's also, so if you see basically in 10 lines of code, you've written a complex neural network. It's not too complex though, but still you've written in some sense, a shallow neural network, but people in the media would like to call this deep neural network. This is 2 layers deep. effectively you can go, there are fancy neural networks which actually go 154 layers deep. So if you see this and multiply it by 80 times, you will get pretty much the deepest neural network. At the moment, it's called ResNet, and there are actually other neural networks also. So if you see NVIDIA doing its self-driving car, it actually deploys a very, very deep neural network to actually understand and simultaneously segment, identify people, identify cars, and things like that simultaneously in a single neural network. And it's an expansion on top of this. So if you can run and if you can understand everything on this code, effectively you should be able to expand on top of it, scale up, and then you should be able to learn what a convolution neural network is, just a residual neural network, LSTM, bidirectional LSTM, and things like that. Then you will be able to understand what NVIDIA is doing or Google is doing, for example. And yeah, we can do all of that. And yeah, let's probably start with our cloud study. Because how many of you are interested in actually running all of this? Would you be interested in actually coding something here? Or would you want to go into the study jam already? Because the study jam is purely into Google Cloud and how to leverage Google Cloud resources. Probably if you're interested there, maybe it's better to switch to the Google Cloud study. I just wanted to give an introduction to what TensorFlow is about, because we are going to run neural networks on Google Cloud. I will give you the access to the resources so that you can actually run a neural network, but it won't be, you wouldn't have to tweak the neural network, or you wouldn't have to do anything. Effectively, you will be leveraging Google's APIs, but I can talk about the API and give you an idea of what's happening behind the scenes. But maybe let's switch there, and then as and when you have questions, let me know. This was a brief agenda that I thought might be something that we could follow, but we're already behind 10 minutes behind schedule. I hope it's fine. So what I would suggest is probably on your laptop, if you can go to Quick Labs, search for QWIK Labs. If you've already done something, if you've not signed up, please do sign up. So that will be useful. What we will do now is we will get access to resources for training on Google Cloud. I will give you a code, effectively, that will let you train on Google Cloud and get some access to Google Cloud resources. So if you've already signed up for Quick Labs, what I would suggest is go to go.quicklabs.com/cloudstudyjams 2019. It's a bit long. It's not too long, though, but it's still a long link. So if you go to this link, what you will see is, oh, it's over here. You should be able to see this page. Did you already see the link? I can put it again over here. So it's that made it worse. So yeah. So if you can go to go.quicklabs.com/cloudstudyjams, you should be able to see something like this. Is everybody there? If you can enroll on baseline, ML, data, AI, yeah, in some order, data, ML, AI. It should look like this. Here, if you click on enroll, you will be taken to another page. Let me know if all of you are already over here. If you are here, then what you can do is you can give in the code 1S, Wiesbaden, 2705. I can again make this larger. So when you're greeted by this code on this page, you can just add this code. It'll give you credits. So every time you want to enroll in the jam into that particular lab, you can give this code and you should be able to enroll in that particular lab, in that particular course. And you should be able to run all the all the chapters there. So if you see that page, I'll just wait for a few minutes before everybody is good to go. So it's 1S minus Wiesbaden minus 2705. Oh, sorry. So just to give you an idea, this code will give you access for the next 30 days. So you will be able to run all the the exercises on this quick labs for the next 30 days for free. So do use this code and try to learn as much as possible and enjoy.